Assalamualaikum and hello to everyone. Welcome back to our channel. Today, I will help you to do tutorial physics 098 chapter 15 electric force and electric field question 2. Let's go. From question 2, we can start with draw a picture of charge A and charge B. Now, in our picture, we've made both charges positive, which makes sense actually because when we have two positive charges, they're going to repel one another, and that means that QB would be pushed to the right while QA would be pushed to the left. Now, how do we know that's correct? Well, the questions noted that particle A exerted a force to the right on particle B. So in this situation, when the two charges are positive, we can see that it's indeed true that particle A is pushing particle B to the right. Now, initially, the distance between them is 13.7, but then the distance will be increased to 17.7. We know from Coulomb's law that the electrostatic force between two charges is inversely proportional to the distance between the charges squared. And one way of writing that idea is to say that the initial force times the initial distance between the charges squared is equal to the final force multiplied by the final distance between the two charges squared. Now, our job is to calculate the final force because we're going to move the charges apart and then determine that new force. So what we'll do is divide both sides in this equation by r squared so that we can isolate that final force. And if we want next we can get a little fancy algebraically and rewrite that squares as r1 over r2 and that entire quantity squared, so it will be look like this. So now that we have isolated F2 and written it in a convenient form, we can go ahead and plug in the initial force, which the question stated was 2.62 newtons, and then we can also plug in the initial distance of 13.7 millimeters and then the final distance of 17.7 millimeters. Notice that in our setup, the millimeters will cancel out, and then when we perform this computation, we should get roughly 1.57 newtons. We notice that the force has diminished, which makes sense because the particles are moving farther apart. We also need to determine the direction of the force because it asks what vector force, and again they want the vector force that particle B is exerting on A. Well, B is exerting on a leftward force on A as we had determined earlier, so the direction for our force would be to the left, and that completes the answer to the questions. Thank you for watching. Hopefully you can understand and enjoy your tutorial question. Bye.